All right, if you're a senior engineer who's deep in the world of distributed systems, you already know the promise of multi-cloud. You also know how painful it can be to prove that it actually works well. So today, we are going to break down a practical framework to do just that. This is the question that keeps us up at night, right? You've built this amazing, complex system that spans multiple cloud providers for all the right reasons. Resilience, using the best services. But when things get real, does it actually hold up as one single cohesive application? Proving it, well, that's the real trick. And the challenges here, they're just different. We're not talking about simple latency. We're talking about the wild, unpredictable beast that is the network traffic between clouds. And each provider's auto-scaling is its own little black box. Their traffic routing has its own personality. And trying to get a single view of observability across all of them, yeah, that alone can completely sink a project. Look, a lot of teams immediately think we need more tools, but you can have the fanciest load generator on the planet and still get results that are totally misleading. The answer isn't another piece of software. It's a mental model. It's a structured way of thinking that forces you to ask all the right questions before you even think about starting a test. And this is that framework. It looks super simple, but it is so powerful. First, we plan. Then we figure out what to measure. And only after that do we execute. Following these 3 steps in this exact order is what separates a truly insightful test from just a bunch of noise. So let's dive into stage 1, planning. Honestly, this is the most critical part of the whole shebang. If you mess this up, you're not just making a mistake, you're basically planning to get useless data. Your success is locked in way before you send a single request. So within this planning phase, there are 3 key things we have to nail down. We have to be crystal clear on our test goals. We have to understand our test topology inside and out, and we have to model our traffic patterns so they look like the real world. Let's take them one by one. First up, goals. What are you actually testing? Are you testing against the service level agreements you promise your users? Or are you trying to validate an internal service level objective between a couple of your microservices? See, the first one measures what your customer actually experiences. The second one is all about the health of your internal architecture. You need to test both for sure, but they are 2 totally different tests. Next, let's talk topology. You have to get specific about your setup. Are your services in different clouds, but say the same geographic region? And a huge one, where is your test traffic coming from? Generating load from inside AWS to test a service in GCP tells you something completely different than generating that same load from the public internet. Understanding these network paths is everything. And finally, modeling our traffic. It's so important to separate north-south traffic, that's users coming in from the internet and hitting your front door, from east-west traffic. That's the internal chatter between your services, which often has to cross from one cloud to another. Testing one tells you about your public-facing resilience. Testing the other uncovers all the hidden latency lurking in your own system. Okay, so once we have a rock-solid plan, we can move on to stage 2, measuring what matters. This is where we make sure we're not just collecting vanity metrics. We need the numbers that give us a real, detailed picture of what's happening. You have to look at all of these categories together to get the full story. For instance, maybe high latency is okay if your throughput is huge and your costs are low. But high error rates, that tells you your system is about to fall over, no matter how fast the few successful requests are. They all have to be looked at in context. And let's get really specific about latency for a second. Average response time is probably one of the most dangerous, misleading metrics out there. It hides all the problems. The 99th percentile, or P99 on the other hand, that tells you about the experience of your unhappiest 1% of users. That's where the pain is. And it's usually the first sign that something is seriously wrong. All right, we've planned our test. We know what to measure. Now for the fun part. Stage 3, execution. Let's make this real and apply the whole framework to a practical example. So here's our setup. Imagine we have a globally distributed API. Part of it's running in AWS, another part is in GCP, and we're getting traffic from users all over the world, North America, Europe, Asia. This is a super common multi-cloud architecture. So how do we test this thing? Well, we follow a logical story. First, we get a baseline. How does each cloud perform all by itself? Then we start the cross-cloud chatter, testing that east-west communication. And finally, we simulate a disaster. What really happens to performance when we have to fail over from one cloud to the other? And this is the kind of thing you might find. The individual baselines, they look pretty good. 150, 175 milliseconds, not bad. But look what happens during that failover. The P99 latency shoots up to 450 milliseconds. This right here is the golden nugget of information this framework is designed to find. Your users would be screaming about that. Now, before we wrap up, let's talk about what not to do. Because knowing the common traps is just as important as knowing the right steps. These are the mistakes that even really sharp teams can make. The number one mistake, by a long shot, is generating all your test traffic from just one place, usually from inside one of your own VPCs. This tells you absolutely nothing about how your application performs over the real internet, and it makes you totally blind to the actual latency of traffic hopping between clouds. Pitfall number 2 is a bit sneakier: forgetting about DNS. It's easy to do. Your load testing tool might just resolve an IP address once and then hammer it. But your real users? They're dealing with DNS caching, geo-routing, TTLs, all of it. There's a real chance your test traffic is taking a completely different, much faster network path than your actual customers are. And finally, please never assume the clouds act the same. They don't. One provider's load balancer might need a warm-up period before it can handle heavy traffic. Another one might have some really aggressive and often undocumented API throttling. You have to know the specific quirks of each provider, because I promise you they will show up in your test results. And that brings us right to the end, to the most important question of all. This whole framework, it isn't about making pretty charts. It's about driving change. So when you see that 450 millisecond latency spike, what's the next step? Do you change your routing? Do you re-architect a service? Or do you maybe even rethink your whole multi-cloud strategy? The test just gives you the data. The real work starts when you decide what to do with it.